Hello everyone and welcome back to Fleming's Math. Today we're covering the Unit 5 test review. Starting with question 1, we have the integral of 4x to the 6th plus 5x squared all over x to the 3rd dx. First we'll move the x to the 3rd up to the top and making the exponent negative. So we have 4x to the 6th plus 5x squared times x to the negative 3. When you distribute x to the negative 3 inside the parentheses, we get 4x to the 3rd plus 5 times the x to the negative 1. Now, 5 times x to the negative 1 can be rewritten as 5 times 1 over x. So we have the integral of 4x cubed plus 5 times 1 over x. Well, the integral of 4x cubed is going to be 4 times x to the 4th over 4, and those 4's will cancel. Now, I want you to remember something. You recall that the derivative of the natural log of x is 1 over x. That means the integral of 1 over x dx must be natural log of x plus a constant. Well, it's actually the natural log of the absolute value of x, because we have to make sure that we don't take the natural log of a negative number. So, the integral of 1 over x dx is the natural log of absolute value of x plus a constant. So that brings us back down to here, where we have this 5 times 1 over x. Well, the integral of 1 over x, as we just mentioned, is the natural log of the absolute value of x, and we just multiply by the 5 in front, and we add our constant. So our final answer is x to the 4th plus 5 natural log of the absolute value of x plus c. And here's number 2. We have the integral of secant times tangent times e raised to the secant theta d theta. In this case, we're going to let u equal secant theta. And the derivative, or the du, would be the derivative of secant, which is secant theta tangent theta d theta. And that works out perfectly because we have secant theta tangent theta d theta within our problem. So now we're ready to rewrite this. The secant theta becomes u, so this will be the integral of e to the u times du. The integral of e to the u is equal to itself, so it's e to the u plus c. And then we simply rewrite u as secant theta, so our final answer is e raised to the secant theta plus a constant. We're going to skip problem number 3. In question 4, we're finding the definite integral from negative 1 to 1 of 1 over x plus 2. I'm going to use u substitution, and I'm going to let u equal x plus 2, which means du is going to be dx. So to rewrite the integral, it's the integral of 1 over u times du. Now, you'll notice that I changed the limits of integration. That's because if negative 1, which is the lower limit, if negative 1 is equal to x, I can plug negative 1 into this expression and add 2. So u would be negative 1 plus 2, which is positive 1. So my new lower limit is 1. Now plug in positive 1, which is the upper limit, plug in positive 1 for x here, so u would be positive 1 plus 2, which is 3. So 3 is my upper limit. Alright, so I'm taking the antiderivative of 1 over u and evaluating it between 1 and 3. Well, as we saw in question 1, the antiderivative of 1 over u is the natural log of the absolute value of u. And we're going to evaluate that between 1 and 3. So we'll plug in the 3 first, and then plug in the 1, and subtract in between. So we have natural log 3 minus natural log 1. And natural log 1 happens to be 0. You can confirm that with a calculator if you need to. But natural log of 1 is just 0. So our final answer is natural log 3 minus 0, or just natural log 3. And here's number 5. The definite integral from 0 to 1 of x times the square root of 1 minus x squared dx. We'll use u substitution and let u equal 1 minus x squared, which means du is going to be negative 2x dx. Now, in the original problem, we see x dx. So we want to isolate the x dx here. So to do that, we'll divide by negative 2 on both sides, which is the same thing as multiplying by negative 1/2. So on the left, we get negative 1/2 du, and on the right, we have x dx. So we're ready to rewrite our integral. We have the negative 1/2 constant that we would pull out in front. The square root of 1 minus x squared becomes the square root of u. And of course the x dx is written as the negative 1/2 du. So here's our new integral. And we change the limits of integration as well. Over here, the lower limit is 0. 1 minus 0 is 1. So the lower limit over here is going to be 1. In the original problem, the upper limit x is 1. So if we plug 1 in here, that's 1 minus 1 squared. Well, that's going to be 0. So our upper limit is 0. So we have negative 1/2 times the integral from 1 to 0 of the square root of u du. That becomes u to the 1/2. And then the antiderivative of u to the 1/2 is 2/3 times u to the 3/2. Now we will evaluate that between 1 and 0. So we plug in the 0 first. And 2/3 times 0 to the 3/2 is just 0. And then we plug in the 1. And 1 to the 3/2 is just 1. So that's 1 times 2/3 is 2/3. So that's 0 minus 2/3 is negative 2/3. And then we multiply that by the constant, which was negative 1/2. So negative 1/2 times negative 2/3 is positive 1/3. In questions 6 and 7, they're asking us to find the new upper limit and the new lower limit for this expression if we were to use u substitution. So imagine using u substitution, and u is equal to 5x squared minus 2. Then we would just simply take the original upper limit, which is 5, and plug that in for x. So that's 5 times 5 squared minus 2. That's going to be 125 minus 2, which is 123. So 123 is our new upper limit. The new lower limit is, again, using u equals 5x squared minus 2, but this time plugging in the lower limit of radical 2 in place of the x. So the square root of 2 squared is 2, times 5 is 10, minus 2 is 8. So 8 is our lower limit. And here's number 8. It says the graph of the function shown below consists of a quarter of a circle. That would be this space here called area number 2. And 2 line segments. All right, here's line segment 1, here's line segment 2 over there. So it says find the definite integral from negative 2 to 6 of the function. Well, the definite integral from negative 2 to 6 is simply the net area of all the areas added together. So what is the net area? Well, we divide this up into 4 different areas. Area 1 is this triangle. Area 2 is the quarter, or 1/4 of a circle right here. Area 3 is this triangle, and area 4 is this triangle. So let's calculate area 1. That's a triangle, so that's 1/2 of its base times its height, so that's 1/2 2 times 2, which is 2. Area 2 is the quarter of a circle, So a quarter means 1/4. And because it's under the x-axis, it has to be negative. So it's negative 1/4 of pi times the radius squared, where the radius is 2. Well, 2 squared is 4, so 4 times 1/4 is just negative 4/4 times pi, which simplifies to negative pi. Area number 3 is a triangle. It's below the x-axis, so we consider it as being negative. The base is 1, and the height is 2, so that's negative 1/2 times 1 times 2, which is negative 1. Finally, area number 4 is also a triangle. Its base is 3, and its height is 2. So that's 1/2 of 3 times 2, which comes out to be 3. Now the net area is simply adding up these 4 different areas together. So that's 2 minus the pi minus the 1 plus the 3 comes out to be 4 minus pi. Number 9, find the function capital F of x is equal to the integral of 3 over x plus 5 dx, with the initial conditions that capital F of negative 4 is negative 7. All right, so to find this function, we do have to find the integral, which is the antiderivative, and we're going to use u substitution. So u is x plus 5, which means du is dx, or 1 dx. But you see in the problem, we have 3 times dx. We have 3 dx. So what we'll do is we'll just multiply both sides by 3 so that it matches what we have up here. So if du is equal to dx, then 3 du is equal to 3 dx. All right, so we're ready to rewrite everything. We have 3 du, so the 3 will go out in front, and the du goes at the end. And then we'll have this 1 over x plus 5, which is 1 over u. Now we know that the antiderivative of 1 over u is the natural log of the absolute value of u multiplied by the 3 in front, and then plus our constant. Now we convert the u back to x plus 5. So we have 3 natural log of the absolute value of x plus 5 plus c. And then we bring in the condition that f of negative 4 is equal to negative 7. That simply means if I replace this x with negative 4, I can set it equal to negative 7. So let's do that here. It's 3 times the natural log of the absolute value of this negative 4. We replace the x there with negative 4 plus the 5, plus the c is equal to negative 7. Now, negative 4 plus 5 is just 1. So that's the natural log of 1. And we already know that the natural log of 1 is 0. 0 times 3 is just 0. So now we have c is equal to negative 7. So that is our constant. C is negative 7. And then finally, we just rewrite the entire equation. And that's f of x equals 3 times the natural log of the absolute value of x plus 5 minus 7. Here's number 10. A particle with velocity at any time t given by v of t is equal to e raised to the t moves in a straight line. How far does the particle move from t equals 0 to t equals 3? All right, so to answer the question, how far does the particle move moves between a position at 0 to a position at 3. So basically, we need to find the position at 0 and the position at 3 and subtract them. Well, to find the position at 0 and the position at 3, we would simply find the antiderivative. The antiderivative would give us the position at 3 and the position at 0, and it will automatically subtract them because that's built into that formula. So to answer this question, we simply need to evaluate the integral from 0 to 3 of the function e raised to the t. Now, we know the integral of e to the t is equal to itself, So we evaluate e to the t from 0 to 3. Plug the 3 in first, and then plug in the 0 and subtract in between. So that's e to the third minus e to the 0. And you can just put that in your calculator. We know e to the 0 is 1. So just evaluate e to the third and then take away 1. And your calculator should give you this 19.086. As a reminder, since it does say write what you put in the calculator, you can actually use your calculator using the integral feature of your calculator to evaluate this integral. So let me just remind you quickly of how to do that. So you would hit the math button, go down to function integral, which is line number 9 here. And then you just simply plug in your lower and upper limits. The lower limit is 0. And then that upper limit's 3. And then you go over to and type in the actual function, which is e to the x. And then you type in, you've got to type in the dx over here as well. So put the x there. And then press enter. And there it is. The value of the integral is 19.085. Which is the same thing we got here. All right, number 11. If f is the antiderivative of this function x cubed over x squared plus 3, where f of 1 is 7, find f of 5. All right, so it gives us f of 1, and we're trying to find f of 5. Now, lowercase f is the antiderivative, so that is an indication that we do need to find the antiderivative of this function. And then we're going to actually find the definite integral between 1 and 5. We know it should be between 1 and 5 because those are the two x values that are given in this information. So we're going from x equals 1 to x equals 5 of this expression. We're going to do this on the calculator, just like we had mentioned before. So let me pause, let's pull up the calculator, and we're going to go into the math menu. Alright, here we are. Calculator's pulled up. Let's press the math button. Let's go down to line number 9, which is the function integral. And our lower limit's 1, and our upper limit is 5. And we type the equation in. That's x raised to the third power divided by, and you want to be careful here, you definitely want to use a parentheses around your denominator. So that's parentheses and then x squared plus 3, and then put in the dx here. Alright, let's press the enter button. Alright, and that is the value of this integral. So over here, excuse me, we can replace this integral with the value of 9.0811. Now we know that this definite integral is equal to f of 5 minus f of 1, because f is the antiderivative. And you just plug in the upper limit of 5 first, then the lower limit of 1, and subtract. Well, we know that f of 1 was given to be 7. So 9.0811 is equal to f of 5 minus 7. Just add 7 to both sides, and we get f of 5 is equal to 16.0811. And that's it. And our last question here is number 12. You jump out of an airplane, and before your parachute opens, you fall faster and faster. Your acceleration decreases as you fall because of air resistance. The table below gives your acceleration A in meters per second squared after t seconds. Estimate the velocity after 5 seconds using the trapezoid rule. Alright, these numbers are giving us our acceleration, and to estimate the velocity, we need to find the integral of the acceleration. So velocity after 5 seconds is the definite integral from 0 to 5 of the function. Well, we estimate that function using trapezoids. So the first trapezoid is going to go between 0 and 1, and we know that the formula for the trapezoid is 1/2 of height 1 plus height 2 times the width. So that's 1/2 of 9.74 plus 8.28 times 1. Then the second trapezoid will be from 1 to 2. So that's 1/2 of height number 1, which is 8.28, plus height number 2, which is 6.32, times the width of 1. And then we just continue to repeat that. The next trapezoid would be from 2 to 3, and its heights, the two heights are 6.32 and 4.97. So that's this calculation here. The next interval, the next trapezoid will go from 3 to 4. The two heights there are 4.97 and 3.88. So here's the calculation for that trapezoid. And then the last trapezoid goes from 4 to 5, and those heights are 3.88 and 2.95. And this is the calculation for that last trapezoid. Then you simply put all of this in your calculator, and if you had looked at the previous answer key, it was set up a little bit differently, but the calculation was the same. So putting all of this in the calculator, you get 29.795 meters per second. And then this is just a verification here that that this is exactly what I was getting on my calculator. Just put everything in just like it was written on the page over here, and I did get 29.795. Alright, that concludes the video on the Unit 5 test review.